Hi. I'm Rob Enns from Juniper. Just wanted to talk a little bit about why you might want to throw some XML into the bag of tricks you use for managing your network. So just to kind of motivate this, big routers, even small routers, are hard things to manage. Their configurations are complicated and large, and they're getting larger. They generate a lot of operational data that needs to be sifted through and managed and saved and stuffed into databases. Operators are always asking us or looking for better ways to manage their networks. And XML is something that we think is worth exploring as a way to solve some of these problems. So I think all you guys already know this, but XML stands for Extensible Markup Language. Really, the key thing about it to remember is that it's a self-describing data format. You can write a program to parse an XML document, and the program will know when it looks at a data item exactly what that is, because there's a little tag in front of it and behind it saying this is that thing. So there's no ambiguity there. All that makes this easy to understand and easy to parse, and because it's all encoded in ASCII, it's easy to debug. And of course, XML is a widely implemented set of standards, which is always nice. So why XML for network management? Well, the network devices are really good, it turns out, at generating a lot of hierarchical data, routing tables, interface hierarchies, configurations, and XML turns out to be a really good way at describing hierarchical data in a standard way. So XML is definitely not rocket surgery. There's some real simple rules for marking things up with tags. You can stick attributes in tags, and there are things called namespaces that let you work with tags from different namespaces within the same document. And just by way of example, here's how you might mark up a route using XML. So right off the top, some of the advantages. It tends to handle forward and backward compatibility pretty well. If you're a client using some XML data and you see a tag that you don't understand, you can typically ignore it, because as long as all the tags you're looking for are there, you can get your job done, which makes it easy for router vendors to go ahead and add more features without breaking existing clients. That's something that is typically hard to do when you're writing management scripts to do screen scraping, and every time the router vendor adds more lines to the screen or changes something around, you have to go back and revisit all your expect scripts. There's a bunch of available tools for working with XML. There are parsers, IDEs, and there's a lot of people that know how to use those tools. And again, it's widely implemented standards. A couple of interesting data definition standards related to XML are DTDs, which give you the structure of XML documents, which is nice really only for the fact that you can then have a parser validate that a document matches a particular DTD before you go off and do something with it. And then there are XML schemas that add semantic information as well to the data definitions, things like data types, ranges of acceptable values, regular expressions that values need to match, relationships between the data items, things like that, documentation. So all good things, good stuff. The other real popular or real powerful standard in this area is the XML Extensible Style Sheet language. It was originally intended for taking XML and rendering it into a browser display or something like that, but it turns out to be powerful enough to do generic transformations of XML into other stuff, where other stuff might be more XML, it might be text, it might be anything. And that's cool because you can take two XML documents and combine them together, you can throw stuff away, you can add new stuff, rearrange hierarchies, sort elements, things like that. So just a pretty picture, XSLT processor takes an XML document on its input, takes an XSLT style sheet telling it what to do, and produces something on its output, which could be XML, text, or whatever. And finally, the last standard that we like is XPath, which is a way to describe parts of XML documents. So you can reach into an XML document and pick out the stuff you're interested in. It's kind of Unix-like path expressions. Just in the example there, you can see if you've got a document that might describe everything in a chassis, you could use that first example to go and pick out the serial number for every component in your chassis. The second example shows how you would pick out everything with a temperature of over 40 degrees. Last example says, go to parsed by B, get me its status. So where does this all apply, or where can this all apply for network management? So network monitoring, a lot of people still write expect scripts to do things like monitor protocol adjacencies and things like that. If you're writing scripts to go out and grab stuff from a router and do something with it, using XML and XSLT makes it all more easy to implement, a lot more exact. You can just go off, grab the data, run it through an XSLT transformation, and toss it up on your web page without ever having to really get your hands dirty and throw stuff into some Perl variables and mess with it in that way. So just kind of as an example, hardware inventory, you could go off and grab an inventory on a periodic basis from every router, run it through a transformation and toss it into your database, either by transforming it into SQL statements to throw it into a relational database, throwing it into an XML database maybe. I think the real killer app for XML, though, is in configuration and provisioning. So imagine putting device configuration into XML. And that way your configurations actually become malleable data without you having to write n different vendor configuration parsers. If you had a vendor-independent configuration model to your network, you could then add snippets to it, delete snippets to it, and then transform it into device-specific configurations, vendor-specific configurations when it's time to go apply that to a device. So for network-wide provisioning, I think I just said this, but you might also have a vendor give you an XML schema for what the configuration is that his device can support, and drive your provisioning tool off of that, so that you can do validations right within your provisioning tool based on the schema that the vendor provided you before you take and hand that configuration off to the device. My third free picture. Take a bunch of XML from a bunch of different databases, mangle it together into configuration, then run that through a vendor-specific configuration into a device config and push it out to the router. And the last example, just the idea that everybody when they sit down at a router that is behaving strangely kind of has the 5 commands that they do to triage the box. Well, if you had a script to do this by picking out the data as XML, run it through a transform to just toss out the stuff that's known good and highlight the stuff that's abnormal, throw it up in some kind of report format for people to triage, and avoid doing that initial 10 minutes of triage yourself. So just to wrap it up, I think XML really can simplify things. There's a lot of tools out there that people are familiar with and know how to use. It's easy to debug because it's just sitting there in ASCII. There's no complicated binary format that you need to sort out if things aren't working. It's used in a lot of different industries, so you're going to find people from the database world and so forth that know how to use it. You can take your database, there's XML interfaces to all the big databases these days, so if you're able to keep the data in one format from its source right to its ultimate destination in the database, it's going to make things easier all the way around. And finally, because it's self-describing, you're a lot less likely to get hosed by your vendor when the vendor adds new features, changes things around. The vendor's free to change the CLI output to make things better without fear of breaking expect scripts of the customers. And that's it. Any questions?
Excuse me, I have a question. Just regarding using XML for monitoring, what advantage does it have over SNMP using a MIB? Like, I don't see any advantage of using XML because the MIBs are like the DTDs and the data is still there, so I don't see the point.
Yeah, a lot of people use SNMP for monitoring and it works fine. I think the case frequently happens where the data that people want to monitor isn't available in SNMP, so they write expect scripts to go monitor what they're after, and that's when you end up in this version hell where you upgrade your router software and all your monitoring scripts break.
But shouldn't that be what we are aiming at, like giving a bigger MIB coverage of things, or?
That's one way to skin the cat.
Is that an answer, or?
There's more than one way to solve these problems. I think for monitoring, SNMP works out pretty well. So that's one way to do it. Really for provisioning and configuration is where I see XML really working out, and that's a place where SNMP really hasn't gotten any traction at all.
But even for configuration, I would prefer sending a single line of a command instead of typing this 40 lines of XML to do some small task. So,
sorry, can you repeat that?
If I want to make a small change, like add like a new access control list or something, I just prefer typing a single command than doing like 40 lines of XML.
Right, I certainly wouldn't expect people to type XML. This is really a machine, something that machines should do. And it's trivial for machines to close every open tag and things like that, and it doesn't really cost anything to do this from a script. Certainly wouldn't want an XML-based CLI. That would make me insane.
Just a comment on the SNMP versus something else. One of the problems with SNMP is that you cannot get a data structure in an atomic way. So you can only get one field at a time. That becomes very cumbersome to do things like routing tables, routing entries, etc., etc. So that's a major drawback with SNMP.
And sort of follow up on that, most people can usually hack something out that looks like XML real easy. SNMP requires you writing MIBs, and MIBs are not fun to write.
Okay, thanks very much.